Hi, y'all. So today we're evaluating composite functions. We're going to start with equations, which might feel kind of familiar, and then we'll move into graphs and tables, which might also feel familiar, but we will check them out. So the idea here is this new notation. So we've seen the filled in circle before, that means multiply, but this is an open circle, right? So you can see here this open circle. That open circle means composition. It means basically we're going to take one equation and put it inside of another equation. So for this one, if it says f of g of x, so since this says f of g, we write, I'm just going to write this really fast, f of g of x. It's not pronounced fog. I know it kind of looks like fog, but it's not. It's f of g of x. So basically this means we're going to take the g of x function and put it inside of the f function. So if it says f of g of 3, that means we're going to take the 3. We're going to replace the variables in the g equation with 3 and then calculate that. And then we're going to say, okay, whatever number we get here, we're going to take that and put it into the f function. So we'll try 3 of them together here. So we are going to start with this first one. It says if f of x equals 3x minus 5 and g of x equals x squared, find f of g of 3. So we're finding f of g of 3. So we're going to start by finding g of 3. So I'm going to take the g equation, which is x squared, and I'm going to replace the x's, all x's that are there, I'm going to replace them with 3's. So this x right here is going to be replaced with a 3. 3 squared is 9. So g of 3 is 9. And now we're going to go ahead and plug that 9 into the f equation, right? So I'm going to take the 9 and I'm going to plug it into f. F, as we know from here, says 3x minus 5. So 3x minus 5. And we're going to plug in that, we're going to substitute the 9 in for the x there. So we would have 3 times 9 minus 5, right? 3 times 9 being 27, minus 5 being 22. So I would say that f of g of 3 is equal to 22. Okay. Go ahead and try this second one. Press pause if you need more time. So for this one, it says f of g of 12. So I know that I'm doing f of g of 12, which means first I need to start on the inside parentheses, right? So I'm going to do g of 12 first. My g function is the square root of x minus 8. So I'm substituting the 12 in for the x. So I'd have 12 minus 8 inside of that square root. Square root of 4. Square root of 4 as is 2, right? Square root of 4 is 2. So that is g of 12. G of 12 is equal to 2. So now I'm going to find f of 2. F of 2. The f of x equation is negative 4x squared plus 2x. So you may notice here that there are two places where x shows up in our function. We're going to plug the 2 into both of them, right? So I'm going to have negative 4 times 2 squared plus 2 times 2. I'm substituting that x in for 2. And I'm going to use PEMDAS if you need that to remind you. I'm going to start with my exponents. That would be 2 squared would be 4. 4 times negative 4 is negative 16, plus 4 would be equal to negative 12. So I'd say that negative 12 is f of g of 12. You could say the composition of f and g of 12. Cool. Take a moment to pause on that one. If you want to try one on your own, this might be a good one to try. In this equation, we see a very similar one to the first one that we did, right? A little bit slightly different, but f of x is negative 3x plus 4, and g of x equals x squared. This one says find g of f of negative 2. Notice the numbers or the letters, the functions are in different orders this time. So just as we had before, we're going to write them the same way in parentheses, g of f of negative 2. So this means that we're going to plug negative 2 into f to start, right? So our first thing here will be to plug in negative 2. So we have negative 3 times negative 2 plus 4, right? That's my negative 3x plus 4. Remember, I'm substituting x in for negative 2. So that would be 6 plus 4 would be 10. So f of negative 2 is 10. And now we need to plug 10 into the g function, right? That's pretty simple as we have x squared, right? So we have x squared for our g function. We're going to plug in 10 in for that x value there. 10 squared is 100. 100 is your answer for g of f of negative 2. So the order matters, right? Because if we did f of g of negative 2, we'd take that negative 2, plug it into g first, and then into f. Cool, we're working our way out. That probably feels somewhat familiar to you, as you've probably done the equations portion before. We also can do this same composition from graphs and from tables. So if I'm looking at from a graph, right, my x value, right, this is going to be my x value. When they ask me g of 1, they're asking me on the g function, right? When the x is at 1, where is the g function, right? So if I'm thinking about this portion first, g of 1, I see here that I have the g equation or the g function, and I have the f function. I know that's them because they're labeled like so. So g of x is up here. They're telling me that the x value is 1. So I'm going to go to where x equals 1, and I'm going to go find the g function. The g function, of course, is right here. The height of the g function at x equals 1 is positive 4. So I would say that g of 1 is positive 4. I still need to find f now, f of 4. So this is actually asking when x equals 4, where's the f value, right? Or where is the f function? So from my origin, I'm going to go out to x equals 4, and I'm looking for my f function, which is that bottom, the absolute value there. So I'm looking down here. And the height of the f function there is negative 5, right? So I would say that this is equal to negative 5. If you want to pause and try these next few on your own, you can. I'll go ahead and do them as we go. Feel free to pause if you want to check yourself. So for this one, I'm going to start on the inside, starting with f of negative 1. So where's the f function when x is negative 1? So x is negative 1 right here. The f function is already right there. The height of it is 0. So I'm going to have 0 there. G of 0. So my x value is 0. So it would be on the axis here. And then I'm looking for my g function, which would be up here. My g function is at a height of 5. So this answer would be positive 5. All right. Here we see nested value, like nested functions that are the same. So it's going to asks us to find f of 4, and then whatever we get, f of that number. So f of 4 on my x-axis, I'm going to go out to 4, and my function is at negative 5. So that simplifies to negative 5. I still have the function. So now they're asking, where's the function of f at negative 5? So I'm going to go on my x-axis to negative 5, but my function doesn't exist out here, right? My function only exists on this domain from negative 1 to 8, right? It only exists in here. So since negative 5, the function doesn't exist at negative 5, I'm going to go ahead and write undefined. This function is undefined. It doesn't exist. Let's try this g of 2. If you haven't paused yet, I do highly recommend try pausing it, try on your own. So g of 2 to start. So I'm going to go out on the x value to 2 and find g. It's up here, which is at a height of 2. So I have 2 here. And then g of 2, again, which we've already calculated, is positive 2. So positive 2 would be my answer there. So for a graph, I would say when x is blank, whatever the number is, right? What is the height of the function? Or where is the function? Where is the function? All right, so that's what I'm thinking. That's what I'm thinking from a graph. All right, we have one more type, which is from tables, right? Tables just tell us points, right? Discrete points. It could look like a graph. It doesn't tell us if it's continuous, where the lines are connected, the points are connected or not. But they tell us two different functions here. So we have the f function here and the g function here. This means this is the x point and this is the y point for f, x point, y point, x point, y point. And then for the g function, we also have x, and then this would be y over here. So -4, 3, -3, -1. Those are individual points. So for this table, I know this means f of g of -2. So it's telling me that my x value is -2. Where is g? So I'm going to find my x value of -2, and the g value there is at +1. Right, so 1, oops, 1, g of -2 is 1. Now I need to find f of 1. So when the x value is +1, what is f at? F is at 3. So I would say that this equals 3. This answer here. So we're kind of using both tables here in order to find our answer. So let me clear off this. Let's try again. So this is g of f of 3. So first, I'm going to find f of 3. So my x value is 3. What is f at? F is at 4. So I'm going to go ahead and put that here. G of 4. So now my x value is at 4. That's asking for g, which is at 2. So my answer here would be 2. So these are the answers for like this whole problem. That just takes us 2 steps to get there. So the first one will be equal 3, second one equals 2. If you haven't yet paused, there are 2 more problems here. Highly recommend pausing and trying on your own. This one means f of 0, f of 0. So first I'm going to find f of 0. So I'm going to go to where x equals 0. What's the f equation? It's at +1. So now I need f of 1. Right, so I'm going to go to where x equals 1 and go to f, which is +3. So this equals 3. All right. Finally, I have one more. This is g of -4. So I'm going to go ahead and find g of -4. So my x value is -4. G is 3. So I'd say this is 3. So now I need to find g of 3. So g of 3, here's my x value, g is 0. So this equals 0. That means this whole function equals 0 there. So today we learned about plugging into equations, plugging in and locating them on a graph, and using a table to find them. Please ask any questions that you have. Happy to answer them. I will see you guys soon.